Welcome to our today's lesson on molarity. Hope you are going to enjoy the lesson. Molarity of a solution is given by moles of the solute per liter of solution. This is normally expressed in the form moles per dm cubed. And we need to remember that a liter is equivalent to 1,000 centimeters cubed, which is also equivalent to 1 dm cubed. Suppose 71 grams of sodium sulfate are dissolved in enough water, then made to 1 liter of solution. And you are required to determine the molarity of the solution formed. The RIM of sodium is 23, of sulfur is 32, and that one of oxygen is 16. So the RIMs are usually given. Now this is how you resolve it. So this is how you go about it. Mass of sodium sulfate dissolved is 71 grams. So we already know the mass that was dissolved. And the mass of 1 mole of sodium sulfate is 142 grams. Now we get the mass of 1 mole by taking the relative atomic masses of the constituent elements in sodium sulfate. For example, the RIM of sodium is 23. So we shall take 23 times 2. That gives us 46. Then sulfur is only 1 atom, therefore we add 32. Then plus oxygen atoms, which are 4. So 16 times 4. So if you do the sum, it's going to give you 142 grams. Then from there, remember, number of moles is always equal to the mass in grams over molar mass. The mass dissolved in grams, which is 71 grams, divided by the molar mass, which is 142 grams. Molar mass is the mass of 1 mole over molecule. So when you divide the two, you end up with 0.5 mole. And since the solution was made up to 1 liter, then it's going to be 0.5 moles per dm cubed or per liter. So we normally denote moles per dm cubed using capital M. So molarity is normally denoted using capital M, and that's why we shall go ahead and say molarity is 0.5 capital M, which we call molar of sodium sulfate. Let's look at some worked examples. Number 1. Determine the molarity of a solution containing 10.6 grams of sodium carbonate, which is dissolved into 50 centimeters cubed of distilled water, and part B, dissolved in 500 centimeters cubed of distilled water. We are given the RIMs of sodium is 23, carbon is 12, and oxygen is 16. This is how you go about it. We shall take the mass of sodium carbonate dissolved, which is 10.6 grams. The relative formula mass of sodium carbonate will be 2 atoms of sodium, each with an RIM of 23, plus carbon, it's only 1 atom with an RIM of 12, plus oxygen, RIM of 16 multiplied by 3 atoms. So that gives us the RFM of sodium carbonate to be 106. Now for us to be able to get the number of moles, we shall take the mass that was dissolved, which is 10.6 grams, divided by the RFM, which is 106. And that gives us 0.1 mole. Now for part A, we are going to take now the number of moles which we've gotten as 0.1 that was dissolved in the first case into 50 centimeters cubed. Then we say 1,000 centimeters cubed will contain how many moles? So if 0.1 mole was into 50 centimeters cubed, then in 1,000 centimeters cubed, then we had 0.4 moles. And because 1,000 centimeters cubed is a liter, then it is 0.4 moles per liter, which is 0.4 molar. The molarity is 0.4 molar. Part B. The 0.1 moles were dissolved in 500 centimeters cubed. Then we relate to 1,000 centimeters cubed. It will be equal to how many moles? So we take 0.1 cross multiply with 1,000 divided by 500. And that gives us 0.2 molar. Question number 2. Calculate the number of moles of sodium carbonate present in 100 centimeters cubed of 2 molar sodium carbonate solution. So we shall say 2 molar sodium carbonate implies 2 moles in a liter of solution. And a liter is equal to 1,000 centimeters cubed. Now this 100 centimeters cubed would contain how many moles? Cross multiply 2 moles times 100 divided by 1,000. That will give us 0.2 mole. So the number of moles in 100 centimeters cubed would be equivalent to 0.2 mole. Calculate the mass of sulfuric 6 acid into 50 centimeters cubed of a solution whose concentration is 0.25 mole per dm cubed. So in this case, we are given that the molarity, which is mole per dm cubed, is 0.25. 0.25 moles are present in 1,000 centimeters cubed. These 250 centimeters cubed would contain how many moles? So we take 0.25 multiplied by 250 divided by 1,000. So the number of moles in 250 centimeters cubed is equal to 0.0625 mole. But the question is asking us about mass. Now for us to be able to get the mass of sulfuric 6 acid, then we shall take the number of moles multiplied by the relative molecular mass. Now let's find the relative molecular mass of sulfuric 6 acid. So the formula is H2SO4. So we have 2 atoms of hydrogen with an RIM of 1 plus 1 atom of sulfur with an RIM of 32 plus 4 atoms of oxygen with an RIM of 16. So with the RIMM equal to 98, we shall come and say our mass is equal to the number of moles multiplied by the RMM. So 0.0625 moles multiplied by 98, which gives us 6.125 grams. So the mass of sulfuric 6 acid into 50 centimeters cubed of the solution will be equal to 6.125 grams. Another question. When 34.8 grams of potassium sulfate were dissolved in 500 centimeters cubed of distilled water, calculate Roman 1, the concentration of potassium sulfate in grams per liter, and Roman 2, the molarity of the solution, given the RIM of potassium is 39, sulfur is 32, oxygen is 16. So we shall come and say 34.8 grams were dissolved in 500 centimeters cubed. How many grams would be dissolved in a liter of solution? So that is to help us get the concentration of potassium sulfate in grams per liter. So a liter would contain 69.6 grams per liter. What we do is we say if 34.8 grams is equals to 500 centimeters cubed, 1,000 centimeters cubed would have how many grams? Cross multiplication gives us the answer as 69.6 grams per liter. That is part 1. Roman 2, the number of moles in 1 liter. So we already have the number of grams per liter. So we shall say it's equal to mass per liter over the relative molecular mass. Now the relative molecular mass of potassium sulfate is 39 times 2 atoms of potassium, because there are 2 atoms in the formula, plus sulfur, which is 32 RIM, then plus the RIM of oxygen, which is 16 times 4 atoms. That gives us a total of 174. Now for us to get the number of moles, we shall come and say the grams in a liter were 69.6 grams. Divide by the relative molecular mass, which is 174. When you divide the two, you end up with 0.4 molar. So the molarity of the solution was 0.4 molar.